In the begin VI, the watchdog reference was open for us. The motor drive reference was open for us. We just opened the gyro and the servo and we put them in. But there's another element here. The joystick device ref. It's not being written to here. So those of you who have been watching really closely might have seen where it got written. Well, let's just return to the teleop VI. The code that we just added was in the execute state. Remember that in the Robot Main.vi, we have a block which is determining what state the robot's in, and that's feeding that in to this sub-VI. In normal operation, it's going to be sent the execute command, and that's why we put our teleop code here. But the very first time it runs in teleop mode, whether you're switching back and forth or just the very first time, it's going to be running in init. In the init state, the joystick reference is being opened. There's another option, which is to open the references to your devices during the init stage. It's up to you whether you open the reference to things in the init state or in the begin VI, but one warning I'll make, as we'll see in a few minutes when we talk about the autonomous mode within this framework, anything that you open in the teleop VI is not necessarily going to be available in autonomous mode. So keep that in mind as we look at the autonomous mode in the next few minutes. So again, let's return to the execute state. This is where all the code takes place. So just to recap at this point, we've taken a look at the advanced framework. We've seen how there's a variety of sub-VIs, including begin.vi and teleop.vi, which serve to encapsulate the code. There's data wires called clusters, which are sending information around between all of these sub-VIs. And the type of the data is determined by an object called a typedef. We learned how to edit the typedef so that we can change the data type which is being passed around, so that we can, for example, add devices such as gyros and servos and make those devices available all over the place. Another comment I'd like to make at this point is we can put any type of data we want into our cluster. For example, we can add timing information. If we right-click on a robot data in to open the typedef, we can add something such as a timestamp control. We could call this something like switch off time. And we can drag any type of data we want into our typedef. When we save and close our typedef, just like before with the object references, the data is going to be available in this cluster. So we could, for example, do some analysis using that information available in our typedef. We could use the timing function, get date, time, and seconds. This over a little bit. A comparison function, greater than, and if the current time is greater than the switch off time, we could use the select function to send an angle of 0 into our servo instead of the gyro value. And if that comparison result is false, then we can send the angle through. So naturally you would say, well, how do we determine what the switch off time should be? Well, this is where we can take advantage of the init stage. Remember that we can write into this data type just as easily as we can read from it. So we can use this bundle by name function, which is here, extend it downward, and select switch off time. And in the init stage, take the current time, maybe add 10 seconds to it, and put that into the switch off time. And what that is going to do is that is going to allow us to make decisions and store important state data in our typedefs. And this is going to be a very fundamental point of what you're going to need to do to make your robot do all kinds of fancy things. I just want to revisit very quickly the Robot Main.vi to understand how that data is kept when we write into the cluster. We remember that we are initializing all that information in the begin case, but take a close look at the while loop. Here's an object called a shift register. The purpose of the shift register is to provide memory in the loop. It's a bit of an advanced topic within LabVIEW, but it's pretty easy to understand. The basic idea here is that whatever comes out of the robot data output of the teleop VI is going into a shift register, which means the next time through the loop, that old value comes out. I invite you to experiment with this a little bit with execution highlighting, maybe using some simplified examples, because it's important to understand that the data you're putting into that cluster in the teleop VI is kept, and so that you can reuse it. I want to talk a little bit now about the autonomous mode within the advanced framework. Remember that this robot mode is deciding the state of the robot, and all the modifications we just made were in teleop mode, within the teleop enabled state. So if we choose instead to take a look at the autonomous enabled, we see in here we have an autonomous iterative VI. And if we activate the context help, we see this is the autonomous iterative VI. This is called for each autonomous packet received from the driver station when the robot is not disabled. It's used to carry out the autonomous tasks in an iterative style that returns within 20 milliseconds. In the basic robot framework, the autonomous VI ran in such a way that the VI opened, started running, and stayed open until it was automatically shut down by changing the robot mode. Within the advanced framework, you have two choices for how you write your autonomous code. You can write it that same way, and remember, in the basic framework it was called the autonomous independent VI. In the advanced framework, you can use the autonomous independent VI just like you did in the basic framework, or you can use the autonomous iterative. It's important to understand the difference. From the point of view of the Robot Main.vi, the iterative mode is like a process you have to look at every 20 milliseconds. You have to look at it, make all the calculations, and spit it out again. Whereas the autonomous independent VI, it's like a process that you spawn. You tell it to start, you give it the data it needs, and then you forget about it until it's finished. There are advantages to both. My personal recommendation is that you use the autonomous independent VI, unless you're a very advanced LabVIEW programmer. The advantage of the autonomous independent VI is it's much simpler to write, and it's a lot easier to do things like timed tasks, where things go forward for a certain amount of time and then come back. The main advantage of the autonomous iterative mode, if you choose to use it, is that it's a lot easier to pass data between the autonomous mode and the teleop mode. And the reason for that is it's all residing on the same wire, which goes into the shift register. Let's leave that discussion for now and make the assumption that you're going to proceed with the autonomous independent VI. The first thing you need to do when you're deciding your autonomous mode is to return to the begin.vi, go to the very top to the match info. This is where you're firing in the information about which autonomous style you're using. And notice that by default you're choosing independent. If you wanted to change it to iterative, you'd have to make that modification to that constant here. But since it is independent, we can leave it the way it was. The other thing to notice is that the autonomous independent VI reference, which we previously saw in the basic framework, right on the robot main, is being wired into this cluster here. So that's how it knows the autonomous independent VI's location. So let's return to the main program, back to the autonomous enabled. So when the robot is in autonomous mode, it's going to come in here, and even if you have independent selected, it's going to run this VI. So let's open it up to take a look. Notice that the match info, which is where we just checked in the begin.vi, the autonomous style is coming out into this case structure. If it is set to independent, then nothing happens. So it's important to understand a couple things. One, you cannot delete the autonomous iterative VI from your robot project. If you get rid of it, you're going to break the robot main. Even though nothing happens here, because it's in the framework, it's got to be present. But just don't put anything here and leave it blank. And second, if you are going to use the independent mode, then you can open that VI from the Project Explorer, Autonomous Independent, or from the Begin VI by double-clicking on the VI reference.